So hopefully you watched the little video that's here if you're having some questions to understand what a function machine is. Um, I'm going to run through these problems if there's any that you did not understand. So in this situation, we have a function machine that has a 3x minus 1 in it. Okay, so here's a picture of that function machine. And what happened was we dropped in a 3. Okay, we dropped in a 3 into 3 times whatever our x is minus 1. So we put in 3 in here. And when we did that, we ended up getting a 9 minus 1, which is 8. And that ended up being our output. Okay. Now, one way to write this, besides saying substitute in 3 for x, we can write it as f of 3. And that is read f of 3. And that means put 3 in for x and evaluate. See what we get out. They really want the output when your input is 3. Okay, that's really what they want. So in this situation here, they want us to find f of 14. They want to know what is the output when your input is 14. What do you get out when you put in a 14? So we have f of 14 is equal to 3 times, and in place of our x, we're going to put 14 minus 1. And we're going to work this out. So 3 times 14 is 42 minus 1. We get a 41. So what that means is f of 14 is 41. This really is a point too, if we were to graph this. When I put in a 14 for my x, I get out a 41. This would be my x, this would be my y. So you can also think of this as a point. So in this case, I want f of negative 10. And again, we're doing 3 times something minus 1. It's still the same function. So I'm going to be putting in this negative 10. And I'm going to get out a negative 30 minus 1, which is a negative 31. So f of negative 10 is equal to a negative 31. When I put in a negative 10, I get out a negative 31. And again, you can think of this as a point on a graph. Negative 10 comma negative 31, where this is your x, this is your y. On C, this is slightly different. So remember, our function machine was 3x minus 1. In this case, they want to know what is the, if the output is 24, what is the input? So this is what we want to find. So notice it is not f of 24. That would be me putting a 24 in. That's not what they want. We want to know, what did I put in for x to get out a 24? So in place of this f of x, I'm going to put a 24. So I want to know what would make this equal 24. So I go 24 is equal to 3x minus 1. And I'm going to solve this equation. So I'm going to add 1 to both sides. I get 25 is equal to 3x. I'm going to divide by 3. And I end up getting 25 over 3 is my x. So if I put in 25 over 3, I'm going to end up with an output of 24. So in this case, my x would have been 25 thirds. My output was the 24. On 1-35, they're giving us a table. And all of my input values are the top row. These are all of my inputs. These are all of my x's. The bottom is my outputs. These are all of my f of x or my y's. Okay. So again, these are my x's. Let me write it out here. These are my x's. These are my y's. So I need to figure out a pattern here. What is happening? What am I doing to a 1 to get 1 back? What am I doing to a 49 to get 7 back? Has to be the same thing I'm doing a 25 to get a 5 back. So that's what they want you to look for and figure out what is going on with this situation. So again, what am I doing to 1 to get a 1? What am I doing to 49 to get a 7? What am I doing to 25 to get a 5? So if you want to pause and think about that. So for this, what I'm noticing is when I see a 49 and a 25 giving me a 7 and a 5, I know that if I take the square root of a 49, I get a 7. If I take the square root of a 25, I get a 5. And if I take the square root of a 1, I get a 1. So it looks to me like I'm taking the square root of x. Now they want us to complete this table. So the square root of 9 is 3. The square root of 100 is 10. The square root of 4 is 2. The square root of 0 is 0. The square root of 20 is not nice, so you could leave it as the square root of 20, or you could put it in your calculator and give me an approximation decimal. So it's about, okay, about a 4.47, let's say. Okay, but you can leave it as a square root of 20. Now, one of these is going a different direction. I want to know, what can I square root to get a 4? Okay, what can I take the square root of and get a 4? And I know that the square root of 16 is 4. So this right here is going to be a 16. Now, we have practiced dropping things in. We have practiced getting and getting out an output. We've also practiced, so we did that right here. Okay, where on number 1 and number 2, we A and B here, we dropped in an X to get an output. On letter C, we went the other direction. We knew the output and we had to go backwards and find the input. Here we did a combination of all of those. Okay, sometimes we knew our input, sometimes we knew our output. That's what's going to happen here. We've got various function machines that we need to either put the input in and find the output, or figure out what the input was to get a particular output. So this one, I'm going to be putting in a -3. So I'm going to take -2 times my x plus 4. My x is a -3. So I'm going to substitute that in and then I'm going to work that out. So a negative times a negative is a positive. So I'm going to get a 6 plus 4. So my output is 10. On number 2, letter B, I'm putting in a 2. So this is asking me to do 3 times 7 to the power x. And in this case, my x is a 2. So that means I'm going to do a 7 squared. Now you have to be careful with this. You have to do order of operation. Order of operation, PEMDAS. Please excuse my dear Aunt Sally. We do parentheses first. I don't have any parentheses. Then we do exponents. So that means I have to do the 7 squared first. So that's going to give me a 49. Then I do any multiplication and division. They're the same level. I would do them from left to right. So I've got some multiplication here. So I'm going to take 3 times 49. And 3 times 49 is 147. And that's my answer. So you have to be careful. Do not take 3 times 7 and get 21 and then square that. That's not what this is asking. On C, this time we're going the other direction. I don't know what my input is. I'm trying to figure out what did I put in. So what I do know is I got out a 125. So I'm going to put 125 is equal to my function, which is x cubed. And I'm going to do this. So what I'm trying to think of is what can I cube to get a 125? Now on your calculators, you do have a cube root button. Okay. But if you ask yourself, what can I cube to get a 125? Hopefully you'll think of 5. 5 cubed is equal to a 125. So in this case, my input would have been a 5. Now, if you needed help doing that, you can use Desmos. I have Desmos on our Canvas homepage. Let me just get up our Canvas homepage. I have Desmos right here. There's also the scientific calculator Desmos. You could really use either one of these, okay? It is something you can also have on your phone. It is a free app. It's something that I might save. I have it saved up on my, I have Desmos saved up here for myself. But if I'm using this Desmos here and I want to do a cube root, I'm going to come here to this pad, okay, this keypad. And I am going to come over here to functions. And if I scroll, keep scrolling, I will see that here, this one here is any root. So if I do that, I'm going to put the cube root of 125. And you see that it's a 5. If I am doing the scientific Desmos, this one here has it right here. You don't have to go find it. So if I do that, I'm going to put a 3 and then a 125, and you see I get my answer as 5. Okay, so on the next one, we are going to be putting in a -2. There's going to be some here that are going to be a little tricky. This is one that's a little tricky. So I'm going to be taking the square root of something and then adding 1. I'm taking the square root of a -2. Now, a negative times a negative is a positive. So if I'm using this Desmos here, and I'm going to take the square root of a -2, you'll see it's going to say undefined, because a negative times a negative is always a positive. There's no way for me to get a negative when I square anything. So I cannot take the square root of a negative. It's undefined. Okay. So this one right here, this piece right here is undefined. So this is going to be undefined. or no solution if you want to say it that way, because I cannot take the square root of a negative. So that one's there kind of as a trick. On E, we're going to put in a 2. So I have a little bit going on here. I'm going to have my 2, and then I'm going to have plus 3, and then I'm going to have 2 times my 2 minus 5. So I had 2 places here. Make it a little smaller. Here and here that I had to put in my x. Okay, so now I'm going to compute this. On top, I'm going to get a 5. On bottom, I'm going to get a 4 minus 5. Now, when I work that out, I'm going to get a 5, and on bottom, a negative 1. So my output is a negative 5. On F, we're trying to find the input when our output is a 99. So I'm going to put that in for this. I'm going to go 99 equals x squared minus 1. And I need to figure out what that is. I'm going to work it out. I'm going to add 1 to this side. I'm going to add 1 to this side. Whoops. Now, when I add 1, I am going to get 100 is equal to x squared. Now what I'm going to do is I'm going to take the square root of both sides. So when I take the square root of both sides, I have to be careful. When I take the square root of a 100, anytime I take the square root, I always get a positive and a negative. This is one that's also kind of a trick. There's going to be 2 answers here, because a positive 10 squared is a 100, and so is a negative. So I get a positive and a negative 10. You want to be careful with that. We're going to get 2 answers. Now, if I'm putting this on my calculator, it will not give me 2 answers. It will only give me the positive 10. But when you square root, you will always get a positive and a negative answer. On G, let me just make sure I hit every one of these. Okay, yeah, on G. So on this one, I also have the output. Now, these symbols here mean absolute value. And absolute value is how far something is from 0. So kind of as an example, if I have a number line and I have 0, and I have a positive 3, sorry, a negative 3, and I have a positive 3, and I want to know how far are these from 0. The distance from here to here is 3. So 3 is 3 away from 0. But the distance from here to here is also 3. So the distance from negative 3 to 0 is also 3. So what happens is, if I'm taking the absolute value of 3, I get a positive 3. If I'm taking the absolute value of a negative 3, I also get a positive 3. I always get a positive back when you take the absolute value. Always get positive back when you take an absolute value. I'm going to abbreviate absolute value. So in this case, this is asking us, what can I take the absolute value of to get a negative 3? Well, we saw that when I take the absolute value of a positive 3, I get 3. We saw when I take the absolute value of a negative 3, I get 3. So this one is not possible. So this is impossible, no solution, undefined. Any of those will work. That's another one where they're trying to trick us. Okay, on H. So on this one, we're going to be putting in a 4. I have 1/2 times 3 to the power 4. So again, remember order of operation. I am going to have to do this 3 to the 4th first. And if I do 3 to the 4th, let me just get my Desmos calculator again. And I am trying to do 3, 3, and then my raised to any power is this one right here. So 3 raised to the 4th. And if I'm typing this on Desmos, what I can also do is I can type in the 3, and if I, on my keypad, on my keyboard, hit Shift and 6, it will automatically bump it up as an exponent. And then I can do 4. And you see, I end up getting an 81. Okay. So this is going to be 1/2 times 81. So I'm going to take half of 81. Okay. And half of 81 is going to be 40.5. 40.5. And that's going to be my answer. On letter I, I'm going to put in a -4 into the absolute value. So I'm going to put a -4 and take the absolute value of -4, and the absolute value of -4 is a +4. So I'm going to get a 4 minus 2, and my answer is 2. So remember, when I take the absolute value of anything, I'm always going to get the positive of that back. And if it is a positive, I still get the positive back. And on Desmos, there is an absolute value right here. So I could use this and put in a -4, and you see it gave me a +4 back. Okay, on the next page, it says examine the function defined below. Notice that f of 2 is 1. So in this situation, we don't have a function machine with an equation. We have a function machine with a graph, okay, of a line. This is actually a line. And so it says, notice that f of 2 equals 1. That is, the input x is 2, then the output f of 2 is 1. So if I go to 2, let me do it with my little cursor here. If I go to 2, my output is 1. So they're looking at this point right here. Hold on. This point right here, which is really 2, 1. So if I write f of 2, that means I'm putting in a 2 and I'm getting out a 1. But you can think of it as a point 2, 1 if you're looking at the graph. Okay. Now, they're asking us, when the input is 1, what is the output? So right now, they want us to find f of 1. So I'm going to go to my graph, and I'm going to go to 1 on my x, and I'm going to go to I hit a point. So that's going to be this point right here, and that point is 1, 3. So when I put in a 1, let me just write this so I color code. When I put in a 1, I get out a 3. Another way to write that is 1, 3. So the next one, so here, let me write that down here. So f of 1 is 3. Next thing I'm going to do is find f of 3. So if I'm finding f of 3, okay, I am going to go to 3 on my graph. Let me just kind of zoom in here. I'm going to go to 3 on my graph, and then I'm going to go to the point, which is right here. Okay, so right here. So that is going to be 3, -1. So f of 3 gave me a -1. When I have an x being 3 and my input is 3, my output is -1. That would be the point. So f of 3 is equal to a -1. Now they want us to find f of 0. So for f of 0, I'm going to come to 0, and I'm going to come here, and this is where it is, okay? Happens to be what we call the y-intercept, and this point's going to be 0, 5. So f of 0 gave me a 5. When I put in a 0, I got a 5. And I'm just going to also note that that's considered our y-intercept because it's touching on the y-axis. Okay, so f of 0 is equal to 5. Now, Roman numeral 4 is saying, what is x when f of x is -1? So we got to be a little careful with this one. So it says we want to find x when f of x is -1. That is not asking me to do f of -1. That's not what it's asking me to do, okay? That's not what it's asking me to do. I don't want to know what I get out when I put in a -1. I want to know what did I put in to get out a -1. Basically, I know I have something common -1 as a point. So I'm going to go to my y being -1. Okay, so I'm going to come here to my y being -1. And so if I come here to where my y is -1, this is where my y is -1, this green line that I'm writing. And you see that that happened when I had 3, -1. So when they're asking us what x gave us an output of -1, that is -3. So x is not -3, I apologize. It was +3. Okay. But I'm going to the y, and I drew a line at a height of -1. That's where my y is -1. Let me make it a little fainter so we can see through it. Maybe that's a little too faint. So we can see that this line here, I'm moving it to a height of -1, and the x that's at that height of -1 is 3. Examine the function defined at the right. Notice that g of 2 is 5. That is, when the input x is 2, the output g of 2 is 5. Okay, so when I come here and I go to 2, so I'm just going to draw a line at where my x is 2. Okay, so this is where my x is 2. Okay, again, let me make it a little fainter for us so we can see through it. Just get rid of that dot I made. Okay, so if I am trying to figure out what my y is when my x is 2, okay, I'm going to where my x is 2. This is where my x is 2. And where does that hit the graph? Well, it hits right here at 5. So that point there is going to be 2, 5. So that was how they got g of 2 is 5. Okay. Now they want us to do a different one. They want us to do if our input is 1, what is the output? Okay. So this time I am going to go to my input being a 1. Change the color. Okay. So I'm going to go to my input being a 1. This is where my x is 1. You'll notice that it hits the graph right here, And so that point's going to be 1, comma 1. So when my x is 1, my y is 1. So g of 1 is 1. Likewise, what are g of -1 and g of 0? Okay, so I'm going to find g of -1, and I'm going to find g of 0. So let me do g of -1, okay? So let me just change this to red. Okay, so I'm going to go to -1. This is g being a -1. And you see that, I'm sorry, x being a -1, you see that I hit right here. And that's going to be -1, -2. So that's going to be, let me just write this over here. I'm going to write to the side, -1, comma, -2. So my g of -1 is -2. Then we want g of 0. So I am going to move this line where my x is 0. So my x is 0 right here. And you see that it hits right here. That's actually, again, going to be a y-intercept. So that's going to be 0, comma, -1. So when my g is 0, sorry, when I'm trying to find g of 0, which means my x is 0, my output is -1. What is the input? So here we're going the other direction. Okay, it says, what is the input? What is the input if the output is -2.5? In other words, find the value of x when g of x is equal to -2.5. Is there more than one possible solution? So I want to see when the output is a -2.5. So what's going to happen is, instead of having this vertical line checking my x's, I'm going to have a horizontal line. So let's have a horizontal line. Let me get a horizontal line. And we're looking at, was it -2.5? Okay, -2.5. So this is -1, -2, -2.5 is going to be somewhere here. Let me just kind of draw it. Let me get a line like this. Okay. And let me make that line a little less, a little smaller, and a little fainter. Okay, so, okay, I'm trying to see where what x has a height of -2.5. So it looks like it's going to be about here. And I'm going to give kind of an approximation. Let's see. It looks like it's actually, I would say, let me move that dot. I would say it looks like it's here. And that is going to be -2, comma, -2.5. So g of -2 gives me a -2.5. Basically, my x is a -2. Is there more than one possible solution? In this case, there's one solution. Okay, there's one solution, not more than one. And that's the end of this video. Hopefully this helps out anyone who might have questions on these assignments.